Okay, the final talk of the day in this track is by Djordje Anicic from Philip Morris. He'll talk about introducing data science and machine learning in non-tech companies. The question is, like, if you're a big non-tech company, what do? Are you buying solutions, or are you building stuff yourself? So that's the topic of the talk, which will start as soon as we see another video.
Hello? Okay, good. So, hello everyone. My name is Djordje Anicic. I work as a data science manager in Philip Morris, and today, as my announcer said, I'll be talking about introducing data science and machine learning in non-tech companies. So, yeah, I knew this is going to happen. Aha, oh, sorry. I'm trying to go backwards, actually. So I'm going to start with something that pretty much everyone knows. Like tech companies, they have a lot of experience in applying data science and machine learning in their everyday business, and they get huge benefits from it. Now, probably this is the reason why other companies are also evaluating the option to introduce these techniques in their business as well. Now, for the non-tech companies, this might be a very difficult thing to do, this big of a change introducing, because very often they need to start from ground zero. They have pretty much nothing. And making this first step from 0 to 1 is actually the most difficult, but also the most important step that the company can make in implementing these sort of changes. Now, in making this step, a company can take two approaches. You can either decide to invest a lot of money in systems, in expertise, buy everything, but then you raise an expectations as a company. If the results don't come flying in, maybe the company will lose faith that these things can bring any value whatsoever to it. Now, the other approach is more focused, start small, very focused, and build an MVP. Like the minimum viable product. You prove that MVP actually works, and then you start to scale it. You put more resources in it only once you prove that it works. So we at Philip Morris, we decided for the second approach. And today I'm going to show you how our journey from 0 to 1 actually looked like. So our journey from 0 to 1 had a lot of elements. And these elements were kind of connected in a process, in a chain, where actually you fix one thing, it leads to another, then it leads to another. But the most important element of this chain, this process, was actually the first one. And this element was not even a data science or machine learning related thing. It was a business problem, clearly defining a business problem, a business issue that you want to solve that can bring value to your company. Now, other elements are more from data science and machine learning domains, such as like engineering data, training a model, visualizing, automating more and more models, and these sort of things. And I'm going to talk about all of these later on. But here I'm just going to show you, just so you get an idea how our journey actually looked like. But first I'm going to show you how our journey didn't look like. Boom. It didn't look like this. It was actually a very long, exhausting marathon. It was very difficult. And as you know, when you train for a marathon, you want to be fit, flexible, you want to be lightweighted, not carry way too much resources. And this is how we approached it. And basically, at the end of the journey, yeah, the sun shined us and there was a success. But the journey was not that short. It lasted for 365 days, and I'm going to show you now a little bit of specifics from our journey of introducing data science and machine learning to Philip Morris. Now, as I said, this is the runner. As I said, we approached our project with a couple of things in our mind. It was an entrepreneurship project. So that's actually an entrepreneur, a startup within the company, within the big corporation. And it was a completely and extremely cost-effective project. It was, most of the technical development was, everything was done internally. Most of it was done by one person using one PC. And it was done using open source software and, I don't know, Microsoft Office applications and these sort of things. So probably it was done in such a manner that probably every single company that maybe you work for can easily implement it with the right expertise, regardless of its size. And since we built it from scratch, that enabled us to fully customize it to the nature of our business and to the nature of our systems that we already had. And what do we got from this approach? Well, we got flexibility and speed in terms of the development. The trial and error during the development became our best friend, and basically we could focus on the quality of the product. We were not worried about the deadlines. The expectations were not huge. We were working in some silo, and basically when we thought that the MVP was good, and we proved that it's good, then we put more resource in it, and we scale it. Now, these are the 6 elements that I already mentioned of our journey. Some elements are more business content, and some elements are more technical, so I hope everybody here will find something interesting. But the first element, as I said, this is the most important one. It's clearly defining a business problem that you're trying to solve. Now, companies, in implementing data science and machine learning, they might try to do that the other way around, like in the wrong direction, like I tried going backwards on the first slide. By starting from the tool itself. You might hear somebody, some of your colleagues saying, hey, I heard a neural network is something amazing. Let's apply it in our business and increase our profits. But that's actually very wrong. I mean, it's just like a kid who's holding a cube and trying to fit it in a triangle hole. And it's like, why is it not going in? Because it's wrong. So it's much better to start from a business problem. Then you work your way to the machine learning algorithm, but only if needed. Only if traditional means of solving that problem fail. So this is how we approached it. And we started from our business problem. And what was our business problem? Now, I don't know if all of you know, but what Philip Morris traditional business is. We basically produce and sell cigarettes, Marlboro, and these sort of things. But a couple of years ago, we made a huge strategic turnaround in terms of now our mission and vision is to create a smoke-free future. No cigarettes. And one of the ways to do it is actually by providing a smoke-free product alternative, such as IQOS. Maybe some of you seen your friend use it or you're using it. So over the couple of years, we've seen a lot of cigarette users actually trying IQOS and purchasing IQOS. A couple of hundreds of thousands in this region alone. But what happened also in these last couple of years is that some of them were actually, switching back to cigarettes. And now we come to our business problem. We didn't know out of IQOS purchasers who remained on IQOS and who left back and switched back to cigarettes. So we had no idea who our actual users are. Now, I want you just to stop and think why this might be so specific or such a big an issue. Think about banking, telco industries, or I don't know, any streaming application company. They know exactly who their users are. They know what they're using, how much they're using, what they like, what they don't like. They don't have to guess anything. So they build models that will, I don't know, recommend them a best offer or whatever to their users. But here we cannot even start to think about building some recommendation for best offer to our users because we don't even know who our users are in the first place. We need to first identify them. And this is not just specific for Philip Morris company. This is specific for pretty much any FMCG company today. There's a lot of companies that have the similar problem. Now, how we approached it is like we started first traditionally to solve it. Like, we were thinking, okay, maybe still ICOS user is somebody who had some interactions with us last, I don't know, 3 months, 6 months, 1 year. But there were so many interactions and combinations that we couldn't find the right one. So we said, okay, maybe we need to train and build a classification model. But so we started from a business problem, tried traditional means, they failed, and then only then we went in the direction, okay, maybe we need something from data science kitchen. But before building the first machine learning model, we realized that we need to do a lot of things with our data, or the traditional way how we look at data. Now, the next couple of slides are going to be more technical in nature, and I'm going to be talking about all the technical challenges and steps that we had during the training of our first model. The model that needs to recognize who the ICOS user still is or is not. And we start from a scoring sample. Now, the scoring sample, for those with no knowledge of data science terminology, that's actually a label of your data that is 100% true and that you're going to train your model against. So in this case, our scoring was actually the information whether the ICOS purchaser is still using ICOS or he's not. But since we didn't have this information, we had to obtain it. And we actually called our consumers. We did it in a very cost-effective way, a representative sample. And in a couple of batches, it only had one question. The survey had one question. That's why we were so effective and fast. And in a couple of batches, we actually collected 20,000 answers. So for 20,000 answers, ICOS purchases, we know exactly at that moment that, yeah, they are using or they're not using. And we're going to use this one in training our model. Now, the second step is features and consolidation. That's like when you're taking every single piece of your data, of your consumers, and you want to consolidate it on one place. We needed all the data that we have from different sources, but now on one place. And business-wise, logical, consolidated. Now, even before we started with data science and everything, we collected a lot of data on our consumers. Now, our consumers, they are purchasing ICOS, they're purchasing accessories, the gadgets with the they're calling call center, opening our communications, logging to ICOS Club, referring to friends, coming and saying, hey, my ICOS broke, can you replace it? And we actually track like pretty much anything that we can. And like any other traditional company, we store them in our SQL Server databases. But they're stored like separately in the structured tables. But what we needed now was actually to consolidate all these information into one user table, one consolidated user table. And this was actually the first data science job that we actually did. And from this consolidated user table, we were leveraging it as much as we could afterwards. And you're going to see. Basically, in building this consolidated table, yeah, you need technical skills, but what you also need is a very strong business acumen. Technical skills are not enough. You just need somebody who understands the data, who understands the business, and can say, hey, this piece of data is good to have it here, but this one, you should not include it. Now, the third step is actually the features engineering, and that's basically when you prepare your data for machine learning models, for training, because sometimes you need it in some specific format, numerically. Sorry. And we had a lot of specifics and challenges here as well, and I'm just going to name a couple of them, which might be, I don't know, interesting. So one of the issues, one of the challenges that we encountered is, yeah, we collected 20,000 answers from our survey, but that survey might be relatively very small to the potential number of features that we're going to train it against. Now, what am I having in mind? I'm going to go through concrete examples just to show you. So every single consumer has a feature that is called registration city. It's when he buys, registers, and says, hey, I live in Belgrade, I live in Užice. So if you believe that this feature is very important when it comes to the conversion of your consumers, you want to include it in your machine learning model. Now, this feature can have, I don't know, 100, 200 values, But if you want to include it, you need to binarize this feature. So you turn it into 100 dummy variables. But then what are you doing? You're just adding 100 additional features on a relatively small training sample of 20,000 samples. Some cities will just have way too little observations attached to it. What might happen is that, yeah, you might overfit your model, or your model might learn some patterns that will not generalize well. But you still believe that the city feature is very much important, that the difference between different cities is very much important. So what do? Well, you then derive and collect new features. But not on a user level, but actually on a city level. You say, hey, average salary. What is the average salary in the city? What is the city population? Number of smokers in the city? What is the closest border to the city? And how distant is the closest border to the city? And what is the current IQOS penetration in the city? Now, so instead of using 100, 200 dummy variables, you use 10 or 15 continuous variables, which will, to a fair extent, differentiate your cities. And as long as you got it right with these variables, your model will learn patterns that will generalize much better. And it's much easier for the model to train on smaller number of features. Now, the same thing goes for the IQOS sales agent. You say, hey, it's important who sold you and who show you how you use IQOS. But then you have 300, 400 people. You cannot use 300 dummy variables, but you actually use 10 or 15 continuous variables, such as agent's experience in terms of days, agent's experience at the moment of first purchase. Is agent still working? Agent's age, gender. But then again, we come to the point, who thought of this? It's not like you don't read these things in data science guidebooks. You need strong business acumen to understand this one. Why did we, for instance, included distance from the closest border? Because we had a very strong hypothesis from the business that there was actually an outflow of IQOS devices from the cities that were close to the border. And we had a hypothesis that the conversion in those cities is lower. That's why we included some proxy variable to mimic that behavior. Now, I'm going to talk a little bit about numerical features transformation, and this is, again, you transform your features and prepare it for a model. Now, most of the transformations are basically done in the standard way, like linear normalizations, standardization, logarithmic transformations, but we applied some custom transformations to some variables that we saw fit, and I'm going to, again, show you one example. Why we did it? Now, imagine the variable days since the last time a consumer purchased an accessory. Like accessory is some gadget with the IQOS device, and you can buy an IQOS device and later on you purchase an accessory. So if the value of this variable is 0, that means the consumer purchased it today. If the value is 100, that means he purchased it 100 days ago. So it is much better, it is preferred that the value of this variable is lower. But then again, what do you do with the consumers that never purchased any accessories? You need to add some value, attach some value to them. You don't want to attach 0 because it's going to overlap with the best possible solution. So you attach, usually you do, hey, let's put -1. But what do you do then? You create a non-linearity in your variable. Because up until 0, you start from up, and up until 0, it is preferred that your variable has lower value. But after 0, it is preferred that your value has higher value. So it has this non-linearity in its impact. Now, some models, most of the models can handle non-linearity, but some cannot. But also the models who can handle non-linearity, it's better to give them a linear variable than non-linear, especially if you have a small training sample of 20,000 units. Now, what we did is we basically built okay, let's build some exponential transformation which will help us transform the variable. And using this transformation, basically, the value 0 is always 1, and it is the highest value. Every single other value, 1, 2, 3, 10, 500, it is transformed to the value between 1 and 0, but never 0. And then, for those who never purchased an accessory, we can say, let it be 0. And we still have a linearly impacted variable, where higher values are always preferred and lower values are less preferred. And 0 is the least preferred, and that is always the lowest value. So we help our model not to struggle with nonlinearity because it has very low training data sample. Now, after collecting the scoring samples and preparing all the features, basically we were ready to train our first model. And we trained a lot of models, and we are still training a lot of models. And without going into some details like, hey, we had, I don't know, 85% accuracy and these sort of things, we're just going to give you some general takeaways from our models. And this is a typo. It's not SGBoost, it's XGBoost. The tree-based models had the lowest performance because for this kind of problem, I think the lazy learning really is really a negative side for these models. Now, logistic regression proved to be much better, but it was oversensitive to a couple of variables, and you cannot remove this thing with L1 and L2 regularization. So, yeah, probably dropout is much better, and also logistic regression can only identify linear relations. So, building a layers of, let's say, logistic regressions or a neural network of several layers, and again, a dropout as a regularization proved to be the best option. But again, we are constantly training and constantly looking for ways to improve it. Now, when it comes to the accuracy, yeah, we started from very standard accuracy metrics, like ROC-AUC curve, and this is something that you find in, I don't know, in guidebooks and these sort of things. But if you have a very clear business problem, business objective in mind, if you know what you're doing, if you know why are you doing something, then looking at more than these few figures can be extremely beneficial. Like, I like to look, and I always look error analysis. I plot errors, I see distribution of errors, and I compare between the models because it gives tremendous perspective, tremendous new perspective when you compare models, because basically you're comparing models, but only in data observations in which your models are making a mistake. And if your model is making a mistake, you want to be sure that he's making a mistake the way you want it, not the random way. And yeah, granular accuracy is very much important because, look, at the end of the day, everything we do is going to be used by business. It needs to be logical from a business point of view. So just don't look just the accuracy on the entire sample. Look at accuracy on different city levels. Look at accuracy on region levels, channel levels, device levels, device version levels, and these sort of things. It can help a lot. Small recap. So we had a lot of interactions that were already stored in SQL databases in the structured tables. We just took all of them, combined them, created one consolidated user table. Then we collected a scoring sample, trained a model, and we did our estimation of our entire IQOS purchaser database. So now we know who our IQOS users are and who are not. But we didn't store back these things into SQL Server. We wanted to be fast and flexible, as I said. So, and there was a lot of trial and error process. Like, you change the code in the algorithm, in the features engineering, and then you go do everything all over again. So basically, we stored everything in SQLite, which is tremendously faster than storing it in a SQL Server, and it gave us enormous speed. It gave us enormous speed in terms of development. And again, it's free and available on every single PC. So very quickly after we consolidated the entire user table and we did our first estimations, basically we realized, hey, this is something that the entire organization could benefit from. So we said, let's make it available to our entire organization. Because if we do it and nobody sees it, nobody will get a value from it. So we decided to build a dashboard. And the dashboard, we said, it has to be user-friendly, it has to be visually appealing, the content has to be completely business relevant. And we built a Power BI dashboard. Now I have a short video, now 1 or 2 minutes of this dashboard. I think the video is going to have a little bit of lag, but the music is going to be good.
time. Tell me how you feel. Do you feel alright? Gotta keep on moving on. Got each other, keep each other strong. Gotta keep on moving on. Gotta keep on moving on. It's a big, big sky. No sign of fear. With this sun so high, is this changing? Are we waiting for a long, long time? Take a look up here. It's gonna be alright. Gotta keep on moving on.
So the music was good, at least. So yeah, we created a lot of content from a data point of view, like collecting everything, consolidating, train the model, created a dashboard. Then everybody all of a sudden starts using the dashboard, and everybody has their own insights about consumers. We're starting to know our consumers much better than we used to. And when it comes to our objectives as a company, what are our goals when we think, how do we want to communicate and offer something to our consumers? We had clear objectives. We want to the communication needs to be relevant always. Our offers need to be relevant. We don't want to spam them. So we wanted to connect these two areas in such a way, so we decided to build an NBA engine to connect it. And yeah, it's not a National Basketball Association engine. It's actually the next best action engine, next best action for the consumer. So what does this next best action was supposed to do? Well, this thing was supposed to manage all our communications, to manage all our offers to consumers. This thing should create a personalized communications to our consumers. It should handle complexities, such as if there's an overlapping communication. We want this thing to prioritize which communications are important, which offers are more important than others to the specific consumers. So in a nutshell, we want this thing to decide what, why, where, when, how, and how much do we offer or communicate something to our consumers, to our IQOS consumers. Because now we know who they are and who switch back to cigarettes. And believe it or not, we actually built this, and technically it was built like in a combination with Excel and Python. We started building like an application, a custom application, at least for the user input. But then we said, look, let's just go much faster and let's use Excel, and basically it saved us enormous amount of time. Now the Excel part actually is a user input part. The users, the business users are putting here details regarding the actions, how they want to personalize communication, like, hey, I want this text and I want these variables, like first name, his city, and these sort of things. And also the action criteria where they decide, hey, I want this communication to be sent to these consumers who satisfy these criteria. Now the Python part actually takes everything from the Excel, and he takes the consolidated user table where we store like everything that we have on our consumers that we already consolidated in the previous steps, and does the calculation. It does the calculation on action details, handles the complexities, the priorities, who to send what, these sort of things. Then the criterias. He needs to decide which consumers get what. So he takes values from the Excel, and then he checks it in our consolidated user table. True, false, true, false, true, false. Personalized communication, the same way. He takes text, and he takes everything that is customized, the variables on a user level. He creates a customized and personalized communication. What is the output? The output is like completely personalized communication. So far, we've been sending a general and very generalized communications. Now it's going to be completely personalized. Hi, Alexander. This is just an example. The words in yellow are actually the words that we are personalizing. So we created this first model the IQOS conversion model. We trained it on a 20,000 answer sample, and basically that model tells us if somebody's using IQOS still or he's not using IQOS. And this is our base camp. This is our starting point. But very quickly, we realized that if we want to be really consumer-centric, and during the development of MBA, we realized, hey, I think just knowing who our consumers are, that's just not enough. We need like more models now. So we decided to build more models. Models such as propensity to upgrade a device, propensity for a user to purchase an accessory, propensity to refer a consumer, probability to have a certain issue, and these sort of models. So now these models are actually the models that predict whether your consumer is ready for some sort of interaction. Now, what is good about it? The good thing about it is that the scoring sample, the scoring variable, is now something that you already have in your history. So you don't need to call your consumers and ask them about the scoring sample. You already have it in your history. That means we are dealing now with the training data samples of more than 1 million, couple of millions. And from the, I don't know, machine learning data science point of view, that's much more interesting than working on a model that has only 20,000 answers. But we had to start with something. So that was our first 365 days, our journey. It started with a business question. And this was the most essential thing, actually. It was an entrepreneurship project. Most of the development, one person, one PC, 16 gigabytes of RAM, and no GPU. So basically, there's no excuses for any company. Completely resource lightweighted, ready for a marathon. Our first data science job, the consolidated user data. And we leveraged this to a maximum extent. And this is the main data science job. We used then this to train a first model. We used it to build a dashboard. Everybody in the organization now uses a dashboard. And we use this to create an MBA engine. And now this will automate everything. Now, 6 out of 7 of these things are already deployed. The 7 MBA engine is ready. It is in a testing phase, and it's going to be deployed in January or in Q4 this year. What we got from this is that we now understand our consumers so much better than ever before. Our retention strategy of the entire organization is actually completely now relying on this infrastructure. And once we deploy the MBA engine, we're going to automate our entire retention strategy. And we're going to save in costs enormously and bring a lot of increments in the revenue stream. So first 365 days look like this. Now for the second 365 days, we plan to improve in every single element. More questions, we're going to expand. It's not going to be a tiny little team anymore. It's going to be a bigger team. Our IT department is going to help us in putting everything on a server or on a cloud. So this is going to be a solution that's going to really look big corporate-alike solutions. It's going to be a small entrepreneurship solution and these sort of things. And I'm very excited about second 365 days, but what I'm really much more excited about is how on earth is going to look, how is going to look our third 365 days and fourth 365 days. Because if the most difficult step was this one, and it was still so interesting and amazing, I'm just curious to see what the future is going to bring to this area. Thank you very much.